Good morning, everyone. Welcome back to the Deep Dive. We're the place that cuts through all that digital noise, bringing you the really critical nuggets of knowledge from expertly curated sources. Think of us as your guides, helping turn complex tech concepts into, clear, actionable insights. Today, we're actually building on our last deep dive. We covered protecting data with cryptography, remember. Now we're shifting focus to building secure systems, application, and cloud security. It's just such a crucial area in our world today, right?
Yeah.
Especially for any organization that really relies on web apps and cloud platforms.
Indeed. And our mission today really is to explore how we secure that software layer. We're moving beyond just traditional network perimeter defenses. We'll get into the most common web application vulnerabilities, delve into that shift left idea in DevSecOps. We'll also try to clarify the shared responsibility model in the cloud that's vital and talk about managing threats and identity in these very dynamic environments. What's really fascinating here, I think, is seeing how these security ideas directly impact things like innovation, trust, and resilience for businesses.
Okay, fantastic. Let's definitely unpack all of that. Let's dive into the code in the cloud. So for anyone building or, managing digital services, securing web applications, it's just paramount. They are the public face, like you said, which makes them a prime target for attackers, obviously. Now, to help developers and security pros navigate this, we often lean on resources like OWASP, the Open Web Application Security Project. Many listeners probably know the OWASP Top 10, but maybe for those less familiar, could you give a quick rundown of what it is? And maybe more importantly, what's a persistent insight or challenge you keep showing us?
Sure. So the OWASP Top 10. It's a list, updated pretty regularly based on consensus from security experts worldwide. It's basically a guide, right, to the most critical security risks facing web apps. Helps everyone, developers, security teams, even execs focus on the highest impact threats. But, the real insight, I think, isn't just what's on the list. It's how consistent the top few vulnerabilities tend to be year after year. Things like injection flaws, broken access control, they just stick around, even with all the new tech.
Yeah.
So the takeaway really is, mastering these fundamentals, even as they evolve a bit, still secures a huge chunk of your attack surface.
That's a really crucial point. It's like those old problems just keep reappearing in new forms sometimes. Speaking of persistent threats, SQL injection, SQLI. It's been around for decades, a real classic, yet it still causes massive headaches. For those maybe less familiar with the mechanics, how exactly does an attacker use, say, a login form to compromise a whole database?
Right. SQL happens when an attacker manages to insert a piece of malicious SQL code into an input field. Think like a login form, or a search bar, maybe even just a URL parameter sometimes.
Okay.
Now, if the application doesn't properly sanitize that input, basically, if it doesn't clean it up or check it carefully, it might just blindly run the attacker's code on the back-end database. The analogy we used before is like asking a librarian for Smith and they bring you the book. Okay. But if you ask for Smith and also give me the key to the rare books room, well, an insecure app, like a very literal librarian, just does both things.
All right. Executes the whole string.
Exactly. And the impact, it can be devastating. The attacker could potentially read, change, or even delete all the data. They could compromise the entire application. And the worrying thing is how often it still works, Even in modern apps using frameworks, often it's down to misconfigured ORMs, object relational mappers, or maybe some custom query where a developer just skipped the proper checks.
Wow. Yeah, a direct hit on the database, giving attackers just incredible control. But what about attacks that go after the application's users instead of the server itself? Cross-site scripting, XSS, that's another common one on the OWASP list. How is XSS different from SQL? And what's its impact on, say, user trust?
Good question. Yeah, while SQL hits the database, XSS really targets the application's users directly. What happens is a malicious script, usually JavaScript, gets injected into a website that users trust. Maybe an attacker posts some malicious code in a blog comment or a forum post, something like that. If the website doesn't validate and crucially escape that input properly before displaying it, it'll just serve that malicious code up to other visitors. So when an unsuspecting user visits that page, boom, that script runs in their browser, not on the server.
Right, in the user's own context.
Exactly. And from there, the attacker can do nasty things like steal session cookies, basically hijacking their login session. They could scrape sensitive info displayed on the page, or even just redirect the user to a fake login page, a phishing site. Beyond the direct data theft, the real damage is often that erosion of user trust, like you mentioned. If you get hit by something malicious on a site you thought was safe, well, it really damages your confidence in that platform, maybe the whole brand. It really hammers home why validating input and encoding output is so critical for protecting those user interactions.
It's fascinating how the attack surface shifts, isn't it?
Uh-huh.
From the back-end database right into the user's browser. Now, you mentioned frameworks and modern development. Traditionally, security was often kind of bolted on at the end, wasn't it?
Yeah.
That old waterfall model where testing happened right before deployment. But there's been a big shift in philosophy. What does this shift left idea mean for how we build applications today?
Yeah, that shift is crucial. The philosophy is called shift left security, and the name is pretty literal. It means moving security considerations from the far right of the project timeline, the end, testing and deployment, way over to the far left, the very beginning, design, requirements, coding.
Right, integrating it earlier.
Exactly. It's about baking security into the earliest stages of the software development lifecycle, or SDLC, and keeping it there throughout, not just as a final check. Now, it sounds like common sense, maybe, but the real insight is that shifting left isn't just about buying new tools. It's fundamentally about changing the developer mindset and the organizational culture around security.
Ah, the culture. That's often the hard part, isn't it?
Absolutely. That cultural shift is often the biggest hurdle, especially in larger companies with very established, maybe siloed ways of working.
So what is that biggest cultural hurdle you see when organizations try to adopt this? And how does this shift left idea actually get put into practice? Is there a specific framework or culture that helps make it happen?
Well, the biggest hurdle is often that perception, like you said, that security slows things down, or the idea that security is only the security team's job, not my problem.
Right. Throw it over the wall to security later.
Exactly. DevSecOps directly fights that. It's implemented through this movement, DevSecOps, which, again, isn't just tools. It's a cultural and practical approach. It aims to break down those traditional silos between development, security, and operations teams. Get them talking, working together. Security becomes a shared responsibility, something that's integrated into the whole automated pipeline, the CI/CD pipeline, rather than being that final, often painful gate developers have to get through at the very end. The goal is really to empower developers, give them the security knowledge, give them the tools, make them active participants.
Okay, so making it everyone's job, essentially baked into the process. If security is integrated earlier and continuously, what are some of the key, practical things involved? What practices really bring DevSecOps to life?
Yeah, there are several key practices that really make DevSecOps work on the ground. First, probably most important, is secure coding training for developers. You have to empower them, right? Teach them how to avoid common pitfalls like the OWASP top 10 stuff from the very beginning so they're not introducing those flaws in the first place.
Makes sense. Build it right initially.
Exactly. Then you have the automated tools, which are really the backbone for making this efficient and scalable. There's static application security testing, or SAST. This scans the actual source code for flaws before it's even compiled or run.
Okay, like a spell checker for security bugs.
Sort of, yeah. It's great for finding certain types of coding errors, design flaws, things like that really early. But it can't see runtime problems, how the code actually behaves when it's live.
Right.
Then you have dynamic application security testing, or DAST. This probes a running application. It acts more like an actual attacker, sending requests, looking for vulnerabilities from the outside in.
So it complements SAST.
Precisely. It finds things HAST might miss, like issues related to configuration or how different components interact at runtime, but you need a running application to test, which usually happens later in the cycle.
Okay. And you mentioned components.
Right. That brings us to software composition analysis, or SCA. Modern applications are built using tons of open source libraries and third-party components. It's just how software is built now. SCA tools scan your project to identify all these dependencies and check them against databases of known vulnerabilities. Is that version of that library you're using known to be insecure? SCA tells you.
Ah, so managing the supply chain risk.
Exactly, because you could write perfectly secure code yourself, but if you pull in a library with a huge vulnerability, you're still exposed. And, while SAST, DAST, and SCA are all powerful, they each have blind spots. SAST is early, code level, DAST is runtime, external view, SCA is dependencies. The real insight for teams is that you really need a layered approach. Understand what each tool is good at, where its weaknesses are, and integrate them intelligently into your automated CI/CD pipeline. That's how you get comprehensive coverage.
That's a great breakdown of how those tools fit together. It's
Yeah.
clear DevSecOps really transforms how we build applications. But okay, even with great DevSecOps, our securely built apps need somewhere to run. And these days, that's increasingly the public cloud, right? As more and more of our digital life moves to AWS, Azure, GCP, the whole definition of security changes again. It demands a really clear understanding of who's responsible for what. So for organizations moving to the cloud, what's that fundamental model that governs security responsibilities?
Yeah, that's absolutely critical. This brings us to the shared responsibility model.
Yeah.
It's foundational to cloud security. It clearly spells out the division of security duties between the cloud service provider, the CSP, like AWS, Azure, Google, and you, the customer.
Mhm.
And the big misconception, the one we see all the time, is people thinking, okay, we moved to the cloud, security is handled by Amazon now.
Right. It's their problem.
Yeah, and that couldn't be further from the truth. You definitely don't outsource all your security responsibility.
That misconception is definitely out there. And the shared responsibility model itself can sometimes feel a bit abstract. What's a good way to really visualize that split between the provider and the customer?
The apartment analogy usually works pretty well here.
Okay, let's hear.
Think about renting an apartment in a secure building. The landlord, that's your cloud provider, your CSP, they're responsible for the security of the building. That means the main entrance lock, the sturdy walls, the foundation, the fire alarms, the underlying infrastructure, right? The physical data center, the core network, the virtualization layer they run the servers on.
Right, the physical security and the core infrastructure.
Exactly. But you, the tenant that's the customer, you are responsible for security in your apartment. That means locking your own apartment door, closing and locking your windows, not leaving your keys lying around or giving copies to strangers. If you leave your front door wide open and someone walks in and takes your TV, well, you can't really blame the landlord for that, can you?
Makes sense. Your space, your responsibility inside it.
Precisely. So in the cloud, the CSP secures that underlying stuff, the physical hardware, the network fabric, the hypervisor. But you, the customer, are responsible for securing your data, your applications, the operating systems you choose to run if you're using infrastructure as a service, your network configurations within the cloud, like firewall rules, and critically, the configuration of the cloud services themselves, and things like identity and access management, encrypting your data, that's on you.
That analogy really does make it click. It draws a clear line. But let me push on that analogy a bit. When we talk about more abstracted services, like, say, serverless functions, AWS Lambda or Azure functions, or maybe fully managed databases like RDS or Cosmos DB, where does the apartment door end and the building foundation begin? It gets a little blurrier there, doesn't it?
It absolutely does. And that's where understanding the specific service model matters. Infrastructure as a service, IaaS, platform as a service, Panther service, software as service, the line shifts. For something like a serverless function, yeah, the provider manages a lot more. They handle the OS patching, the runtime environment, the scaling, the underlying servers. Their security of the cloud responsibility goes way up the stack.
Okay.
But you are still responsible for the security in the cloud for that function. That means the security of the code you write for that function. Its permissions. What other services can it talk to? What data does it access? How does it handle input? That's all customer responsibility.
Got it. So even if they manage the OS, you manage your code and its interactions.
Exactly. And for a managed database, similar idea. The provider patches a database engine, secures the underlying host, but you're responsible for configuring access controls, managing user credentials for the database, the schema design itself, deciding whether to encrypt the data within the database, network access rules. The customer's responsibility moves up, focuses more on data and configuration, but it absolutely does not disappear.
That deeper dive really helps clarify those fuzzier boundaries with Pellis and serverless. Okay, so sticking with that customer responsibility piece, especially configuration, what is like the leading cause of cloud data breaches we see today? Is there one main culprit?
Oh, absolutely. Without a doubt, it's cloud misconfiguration.
Misconfiguration.
Yeah. This is simply when a user fails to correctly configure the security settings of a cloud service. It often leads to unintended access or exposure. The most infamous example, the one that hits the headlines constantly, is leaving a cloud storage bucket like an AWS S3 bucket or Azure Blob Storage container configured for public access.
The Open S3 bucket.
The classic Open S3 bucket. Accidentally exposing potentially millions of sensitive customer records, internal documents, whatever, to the entire internet. It's often a simple mistake, a checkbox unchecked, a policy written too permissively, but the consequences can be absolutely devastating. It really underscores why careful setup, continuous monitoring using cloud security posture management tools, and automated checks are so vital. We've seen huge breaches traced back to just one misconfigured firewall rule or an overly broad IAM policy.
That's sobering.
Yeah.
Such a small error, such a massive impact. Now, thinking about modern cloud-native applications, containers are everywhere, right? Docker, orchestrated by things like Kubernetes. This tech is amazing for deployment, scalability. But it definitely introduces new security risks, too.
We touched on using a vulnerable image, but beyond that, what are some other key security challenges specific to containers and Kubernetes? You're right, using a container image that has a known vulnerability, maybe an old version of OpenSSL or some library baked in, that's a big one. SCA tools help there. But the complexity of container orchestration, especially Kubernetes, brings its own set of headaches. Misconfiguring network policies within Kubernetes, for example, these control with pods can talk to each other. Get that wrong, and you might allow way more communication than intended, breaking segmentation.
Mm-hmm. Lateral movement risk.
Exactly. Then there's secrets management. How do containers get the credentials they need to talk to databases or APIs? If those secrets aren't stored and injected securely, maybe just put in environment variables or baked into the image. Well, if one container gets compromised, the attacker might grab those secrets and pivot. And then there's the risk of privilege escalation within the cluster itself. Can a process break out of its container? Can it talk to the Kubernetes API server with too many permissions? A small compromise could potentially lead to taking over the entire cluster. It's a perfect example of how new tech shifts the focus. Security isn't just about the app code anymore. It's deeply tied to the infrastructure configuration, the orchestration layer. You need specialized skills to secure these environments properly.
That's a critical point, that shift in focus and the need for new specialized expertise. And one theme that keeps coming up, tying a lot of this together, is identity and access management, or IAM. You mentioned it's even more critical in the cloud than in traditional data centers. Why is that? Why the increased importance?
It's fundamentally because of how you interact with the cloud. In an old-school physical data center, access was often governed, at least partly, by physical factors. You needed to be physically there, or at least on the trusted internal network, to access many things.
Right. Physical barriers mattered more.
Exactly. In the cloud, everything is controlled by code, by API calls. Your entire cloud environment is essentially one giant surface area addressable via APIs. There aren't the same physical perimeters. The network perimeter still exists, but it's much more porous and software-defined. So IAM becomes the primary control plane. It's the mechanism that defines who a user, a service, an application can do what action on which resource. It's the central nervous system for permissions across your entire cloud footprint.
Okay, so it's the main gatekeeper because everything is an API call.
Precisely. Getting IAM right is absolutely non-negotiable for cloud security and compliance. Getting it wrong, well, that often leads directly to those misconfiguration breaches we talked about.
That really clarifies why it's so pivotal.
Yeah.
So drilling down into IAM, how does the actual model work? Thinking about the big players, AWS, Azure, GCP, is it similar across them? And what are the absolute must-do best practices for using IAM securely?
Yeah, the good news is the core concepts, the model itself, are remarkably consistent across AWS, Azure, and GCP, even if the specific names for things differ slightly. You generally have three core components. First, identities. This is the who. It could be a human user, a group they belong to, or increasingly a machine identity like an application, a service, or a role that can be assumed.
Okay, the who.
Second, policies. This is the what. These are documents often written in JSON that explicitly state what actions are allowed or denied, like allow read access or deny delete access. They can get very granular.
The permissions, the rules?
Exactly. And third, resources. This is the where. The policy needs to apply to something specific. Is it this particular S3 bucket, that specific virtual machine, this database table? You attach the policy to the identity and specify the resource it applies to.
Who, what, where. Makes sense.
Now for best practices. The absolute #1 paramount principle is least privilege.
Heard that one before.
You'll hear it again. Grant only the minimum permissions necessary for an identity to perform its specific task. Nothing more. If a user only needs to read from a bucket, don't give them write or delete permissions. If an application only needs to access one specific database table, don't give it access to the whole database.
Seems obvious, but hard to implement consistently.
It takes discipline, absolutely. It's easier to grant broader permissions sometimes, but it creates massive risk. Another key practice, use roles for applications and services whenever possible. Instead of embedding long-lived access keys, like a permanent username and password, into your application code, use roles that grant temporary, automatically rotated credentials. If those credentials leak, the window of exposure is much smaller.
Right, temporary access is better.
Much better. And for human users, especially administrators or anyone with significant privileges, multi-factor authentication, MFA, always, everywhere. It's a huge barrier against compromised passwords.
Non-negotiable for humans.
Pretty much. And one more that's often overlooked. Regularly review and audit permissions. Don't just grant access. Actively look for permissions that are no longer needed. Did someone change roles? Did that temporary project end? Revoke unnecessary access? Stale, overly broad permissions are like leaving backdoors open all over your environment.
That's a fantastic summary of I am the model, and those crucial best practices really drives home its importance.
So, if we were to summarize this whole deep dive, what are the key takeaways? I think the big one is that our approach to security just has to evolve, right? As businesses move from on-prem to these really dynamic applications and cloud platforms, we've seen that securing the applications themselves needs that proactive, developer-focused approach. Mitigating things like the OWASP top 10 flaws, really embracing DevSecOps culture, shifting security left, that's critical.
Building it in, not bolting it on.
Exactly. And then for the cloud, that shared responsibility model is the absolute key concept to grasp. The provider secures the underlying cloud, but we as the customers are responsible for securing everything we put in the cloud, which makes preventing those misconfigurations, getting container security right, and having really tight control over identity and access management. These aren't just tasks, they're ongoing critical processes for any organization in the cloud today.
Yeah, it really paints a picture where the modern security landscape isn't defined just by a network firewall anymore. It's like you said, every line of code, every API call, every single cloud configuration setting, it demands a much more holistic, integrated approach. So thinking about this constantly evolving landscape, security woven so deeply into the tech itself, what do you think is the next big challenge, the next frontier we're going to face in securing these incredibly complex, interconnected systems? Is it maybe AI-driven attacks, getting smarter, the sheer complexity of managing hybrid and multi-cloud environments, or something else entirely just over the horizon? That is definitely something to chew on, where things are headed next. And speaking of the bigger picture and strategy, our next deep dive is going to tackle exactly that, the big picture, risk, governance, and compliance. We'll explore how all these technical security details we discussed today feed into the broader organizational strategy, risk management, and all those regulatory requirements. You really won't want to miss that one. So thank you all for joining us for this deep dive into building secure systems, covering both applications and the cloud. We definitely invite you to subscribe to our channel, Tech AI and Beyond, right here to make sure you don't miss any of our future explorations into the technologies shaping our digital world. Thanks for listening.